Hello everybody, we are going today to try and use the Pythagorean identity to solve some problems. So that is that cosine squared theta plus sine squared theta is equal to 1. So in this first example, we have to find cosine theta if we know that sine theta is 2/3. So what we really need to think about here is rearranging that identity to be something useful. So we can say if that cosine squared theta plus sine squared theta is 1, well, we could rearrange it maybe and say that 1 minus sine squared theta square rooted is going to be cosine theta. So now we can substitute in the 2/3 for sine and hopefully get a good result. So square root of 1 minus 2/3 squared, that's going to be equal to cosine theta. At this point, we could square the 2/3 and let's write that 1 as 9/9. So we 9/9 minus 4/9 square rooted is going to be our cosine theta. From here, hopefully we can see that that's the square root of 5/9. And then the simplest way of writing this, and don't forget to do the plus and minus as well when you square root, is plus or minus square root of 5/9. So there's our answer. Moving on to another example then, this one's slightly more challenging. If sine theta is minus 3/4 and theta is between pi and 3 pi over 2, find cosine theta and tan theta, giving exact values. Well, similar to last time to get started with anyway, we can rearrange the Pythagorean identity again. So we could say that cosine theta is equal to the square root of 1 minus sine squared theta, and then put in the sine theta value of minus 3/4 again. So let's try and do that. Let's save some time this time. Already I'm going to write the 1 as 16/16. And then if I think about minus 3/4 being squared, that's going to be 9/16. So therefore we're going to be left with the square root of 7/16. Now, when we simplify this, we obviously get two answers, the plus and minus of root 7/4. Now, we have to now think that one of these might not be quite right because we're given a boundary here. We are told that theta is between pi and 3 pi over 2. Now, let's think about that on our unit circle diagram here. So our angle is here somewhere, right, in this quadrant. Well, if we think about sine theta and cosine theta here, well already we're given that sine is negative, and of course this is our sine value. Of course sine is negative. And if this is our cosine theta axis, well, that's going to be negative too. We're over here on that axis, right? So we're going to reject the positive value and we're going to write the negative value. We're going to say that cosine theta is negative root 7/4. Now, we've got the cosine theta and we've got the sine theta, so we can use those values to find out the tan theta value. So tan theta is sine theta over cosine theta. And if you remember, sine theta is given as minus 3/4. We have just worked out the cosine theta value, and that is minus root 7/4. And so we can rearrange that by flipping over the second fraction, and we are going to get that sum there. We can cancel the 4's, and we can also cancel the negatives as well, because negative times a negative is a positive. So our final answer is going to be 3/7. So we have tan theta and cosine theta. On to the final example now. This one is even harder again, unfortunately for us. Tan theta equals minus 2. We're given a boundary as well. So find sine theta and cosine theta. Now, perhaps before we get started, we can think about what these values are going to take, the sine theta and cosine theta. Are they going to be positive or negative? And if we have this boundary between 3 pi over 2 and 2 pi, then we're talking about this particular quadrant here on the unit circle. Now, if we think again about the cosine of theta axis, well, it's clearly cosine theta, it will be positive, won't it? We're in the positive axis. But the sine theta, of course, is going to be negative, because if you think of your sine theta axis, we are down here, aren't we? We're negative. So we can already think about that when we get our answers a little bit later on in the question. Okay, so we know that tan theta is -2, and we're going to swap that for sine theta over cosine theta is equal to -2. And from there, we can move that around a little bit, and let's just say that sine theta is equal to -2 cosine theta. And what we're going to do is now when we see a sine theta inside that Pythagorean identity, we will swap it for the -2 cosine theta. So usually we have 1 is equal to sine squared theta plus cosine squared theta. Now we can say that 1 is equal to -2 cosine theta being squared instead of the sine squared plus the original cosine squared theta. From here, we can say that 1 is equal to positive 4 cosine squared theta plus another cosine squared theta, And from there, we can say, well, 1, well, if we collect those up, is going to be 5 cosine squared theta. Rearranging that, we are going to divide by 5 and square root. So we'll have the square root of a fifth is equal to cosine theta. And again, we should probably rewrite that as plus or minus 1 over root 5. If we multiply that top and bottom by root 5, we are going to end up with plus or minus root 5 over 5, which is probably a better way of leaving our answer. And we've already seen that cosine theta must be positive, so we're going to reject the negative. Therefore, cosine theta is equal to positive root 5 over 5. Now, finding sine theta after this point is quite simple because we already know that sine theta is -2 cosine theta. We did that right back at the top. So we can swap this in, -2 times root 5 over 5, which is going to be -2 root 5 over 5. That'll do. And it's negative, and that is exactly what we'd expect. Sine theta is negative. So there we go. Sine theta equals -2 root 5 over 5. Okay, now that completes all of the examples I've got for you now. Have a go at these questions from the textbook. Best of luck.